Hi class. Earlier today in class we talked about dilations, which included transforming an object like this, which is a rectangle, into a smaller rectangle. Say one like that. Okay, and this is not drawn to scale. I haven't applied dilation. I don't know what happens. But just so you know, we talked about this in class today. So basically what happens is we take this larger figure, and because we're going from a larger to a smaller, we multiply it by a fraction, something less than 1. So we would say xy from the larger figure goes to, let's say, 1/3 x, 1/3 y. Okay? And that'll take this figure, this large figure, to this small figure. Because all we do is transform each of these points from this large point to this small point. This is A, B, C, D. This goes to A prime, B prime, C prime, and D prime. Okay? And that's 1/3 of this larger square rectangle here. Alright, so that's what we did yesterday. And I want you to remember, if K is, and let me make that larger so you can see it better. If K is greater than 1, then we have an enlargement. That means we'll go from this to that. Go from the small figure to the larger figure. If K is less than 1, we have a reduction, which means we'll go from this large figure to a smaller figure. And that's what we talked about in class today, transformations. We also talked about, say we had this large square, and we came all the way over here, and we had that. Okay, so what that would mean that this large square, first we translated it, so we moved it over, and then we applied our dilation of 1/3, which gave us this smaller rectangle moved over. Okay, so you may say, I remember K, but where did it come from? Okay, so our xy goes to some other xy. So that's kx, ky, which means this k represents that number in front. In this case, our k is 1/3. Okay? So today, now that we remember this, we're going to move on. Tomorrow, we'll be focusing on triangles. We'll focus on proving triangles are similar by using our side angle side theorems, our side theorem, and our angle theorem, all of which you've learned before. So let's suppose we have a triangle. That looks like that. We're given this angle and that angle. And we have another triangle, a wee bit smaller, but we're also given that angle and that angle. We can show that these two triangles are similar by angle. So this angle is congruent to this angle, and this angle, which is a right angle, is congruent to that angle. Thus, because our angles and triangles all add up to 180, this angle must be congruent to this angle, and we have just proven that these two triangles are similar by the angle postulate or theorem. Okay, let's suppose we're given these two triangles. let's say, let's make this triangle bigger first of all. I don't like it right now. It really doesn't look like it's in a similar triangle, but I want it to look like it's a similar triangle. Let's say that side is the same as that side, it's the same as that side. And then on our larger triangle, let's say this side is the same as this side, same as that side. Okay, because we have an equilateral triangle, because all of our sides are the same, which means all of the lengths are equal, we must have this triangle is similar to that triangle. So let's call this triangle ABC. Let's call this one DEF. I can say triangle ABC is similar to triangle DEF by the side theorem or postulate, whichever one you prefer to go with, because I have an equilateral triangle there and I have an equilateral triangle here. Whether the sides are the same length, which they would not be, because you can see these sides are smaller than these sides, it's really irrelevant as long as the sides are exactly the same. So we just shown that these two were similar by the side theorem. Okay, call this A, B, C, D, E. Okay, and let's say segment AB is parallel to DE. Thus, we know from alternating interior angles that angle A is congruent to angle E. Okay? Now let's say, and we know by, let's say we have angle B. We know that we have angle D by alternating exterior, that angle D is the same, alternating interior, that angle D is the same as angle B. So again, we have by angle triangle ABC is similar to triangle, and we have to be careful here, EDC, because our letters must match up. If they do not, then we cannot say they're the same. We cannot say triangle ABC is similar to triangle DEC, because that is not true. So I'm going to put a big red X through it, like I would do in your paper, so I hope I don't have to do that. But that is not true. Okay? So again, by angle, we've shown that ABC is similar to EDC. So for this last one, we're given two triangles. We have angle, side, and because they're right triangles, that's actually two legs. Angle, side. Okay, now we don't have the angles, but we do have, for these, especially isosceles triangles, which means this angle is the same as that angle, this angle is the same as that angle, because our two legs are the same. But this is a special case of similar triangles, ABC, DEF, that we can say triangle ABC is similar to triangle DEF by our side theorem. Okay, you'll want to write all this stuff down that I'm writing just to make sure you have it for notes in the class when we do the homework. But these two triangles are similar because we got sides, we got one angle, and then we got another side. Okay? So we've done angle, side, and side, angle, side. One big thing that we did yesterday was the circles. And from the video, I asked you in class what we're going to prove. and yesterday it was that circles are always similar. So today, I got a new question for you that I'll ask you tomorrow. We're doing triangles. We had 3 different ways to prove that they were similar. So I'll ask you this before we do any work. Our ways to prove them were angle, angle, side, 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 and side, angle, side. In class tomorrow, you'll tell me what I just told you, that the way to prove triangles that we talked about on the video was angle, angle, side, 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 and side, angle, side. All right, class, that's it. See you tomorrow.